Hello, today we're going to talk about another way to find central nodes in a network. Just like PageRank, this way was also developed in the context of how a search engine might go about finding important web pages given a query using the hyperlink structure of the web. So the first step will be to find a set of relevant web pages. So for example, web pages that contain the query string in the text of the web page, or for some other reason the search engine thinks that this might be an important page to look at. So these are potential authorities, potential pages that are important given the query that the user submitted. These will be called the root set. And so let's say in this example that nodes A, B, and C are these potential authorities. This is the root set. Then the next step will be to find all the web pages that link to any page in the root set. And these pages will be potential hubs. So hubs are pages that are not themselves necessarily relevant to the query that the user submitted, but they link to pages that are relevant. So they're pages that are good at pointing at things that may be relevant. And let's say that in this example, the nodes E, F, G, D, and H are these pages that point to at least one of the pages in the root set. This whole set of nodes, whatever was in the root and anything that points to something in the root is going to be called the base set. And we're going to consider all the hyperlinks that link any node in the base set to any other node in the base set. So there may be many other edges in this network, and we're going to consider them all. And so this is the network that we're going to use in order to find the important web pages. So the difference between this new way, hubs and authorities, and PageRank is that rather than taking the full network, we're starting with a subset of the network. Again, looking at first just the root set, the web pages that may be relevant, and then any page that links to it. And so this will be just a subset of the full network of the web. Now we're going to run the hits algorithm on this network. And the hits algorithm, just like PageRank, works by computing k iterations and keeping track of the score for every node. Now the difference is that the hits algorithm is going to keep track of two kinds of scores for every node, the authority score and the hub score. The first step is to give every node an authority and a hub score of 1. And then we're going to apply two different rules. These rules are going to be similar to the rules that we used when we computed PageRank, but again, now we're going to have to keep track of two different scores. So the first rule is going to be the authority update rule, which says that each node's authority score is going to be the sum of the hub scores of each node that points to that node. And then the other rule is the hub update rule, which is sort of the symmetric thing. So each node's hub score is going to be the sum of the authority scores of each node that it points to. And then we're going to have to do some normalizations because these scores are going to keep growing and growing. So at every iteration, we're going to normalize the hub and the authority score. And so for example, the way you normalize the authority score is you take each node's authority score, let's say J, and you divide the authority score of J by the sum of all the authorities in the whole network. And then we're going to repeat this process k times. Now, this might seem a little abstract at this point, but let's run to an example to see exactly how it works. So we're going to take the network that we had just discussed, and we're going to compute two iterations of the hits algorithm on the network. So just like in PageRank, we're going to have to keep track of the old scores to be able to compute the new scores. And because the first step is to give every node a hub and authority score of 1, we're going to start there. We're going to give every node an old authority and hub score of 1, and then we're going to compute the new scores. So let's start with the authority scores. We look at node A, and we're going to look at what nodes point to node A in order to figure out what the new authority score of A is. And it turns out that C, G, and H point to A. And because C, G, and H all have hub score of 1, then the new authority score of A is going to be 3. Next, node B, nodes D and E point to B. And E and D both have hub score of 1, so B is going to have a new authority score of 2. And so you can see at this point that what we're really doing when we get this new authority score is looking at the in degree of each one of the nodes. And that's what's going to happen. So for example, node C has an in degree of 5. And because all the nodes at this point have a hub score of 1, then C is going to have a new authority score of 5. And then D has 2 nodes pointing to it, so it has a new authority score of 2. And E has in degree of 1, F has in degree of 1, G has in degree of 0, so it's going to have a new authority score of 0. and H has one node pointing to it, so it has the new authority score of 1. Okay, now let's move to the new hub scores. It's going to be very similar, but now instead of looking at the in degree of every node, we're going to look at the out degree. And so, for example, A has an out degree of 1, it points to D, and now we have to look at D's old authority score. And again, because this is our first step, every node has an old authority score of 1, then D does as well, and so A is going to have a new hub score of 1. B points to two things, both of whom have an authority score of 1, and so B has hub score of 2. C has an out degree of 1, so it has a new hub score of 1. D has an out degree of 2. E has an out degree of 4. F has an out degree of 2. G has out degree 2, and H has out degree 1. Okay, so the hub for the new hub scores, all we had to do was figure out what the out degree of each node was. Next, we have to normalize. And so to normalize, we have to add up the authority scores and add up the hub scores. In this case, they all both add up to 15. It's not the case that in every iteration they're going to add up to the same thing, but in the first one they do. So they both, in this case, add up to 15. And so we have to divide all the scores by 15. And so if we do that, we normalize the scores. And now the new authority and hub scores are going to become our old scores. And we're ready to go for the next iteration, which is going to be slightly more interesting since now the nodes don't all have the same authority and hub score. So we have to pay attention at the nodes that we're looking at. So let's start with node A. We want to figure out the new authority score of A. And so we have to figure out what nodes point to A. So C, G, and H all point to A. And now we have to look at the hub scores of C, G, and H, which are 1/15, 2/15, and 1/15. And so we add those up and we get 4/15, and that is going to be A's new authority score. Now let's move to B. B has two nodes pointing to it, E and D, and they have old hub score of 2/15 and 4/15, which adds up to 6/15. And then C has 5 things pointing to it, nodes E, F, G, B, and D, which have these old hub scores that I'm highlighting here. And they add up to 12/15, so that's C's new authority score. D has 2 things pointing to it with old hub score of 1/15 and 4/15, which adds up to 1/3. And so on, right? We can continue doing this for all the other nodes and find all of the new authority scores. Now let's go and try to find the new hub scores. So looking at A, again, now we're not looking at the in degree, we're not looking at who points to A, but who does A point to. And now we have to pay attention to the old authority scores of those nodes. So in this case, A points to D, and D has a old authority score of 2/15, so that's going to be A's new hub score. And then for B, it points to E and D, and they have an old authority score of 1/15 and 1/3, which adds up to 2/5, and so that's going to be B's new hub score. C points to A, and A has an old authority score of 1/5, so that's C's new hub score. D points to B and C, and they have an old authority score of 2/15 and 1/3, which adds up to 7/15. And then so on, we can continue doing this for all the other nodes and find the new hub scores. Next, we have to normalize. So we have to add up all the authority scores. In this case, they add up to 35/15. So we have to divide every new authority score by 35/15. So if we do that, these are the updated normalized scores. And we do the same thing for the hubs. So we add up the hub scores for all the nodes, which adds up to 3 in this case. And so we have to divide every new hub score by 3. And then these are the updated normalized scores. And so these are our final new authority and hub scores after 2 iterations of the HITS algorithm. So just like in PageRank, we wonder what happens to these scores if we continue iterating the algorithm over and over and over again. Is it going to converge to a unique value? Well, let's take a look. So here are the scores that we just computed for k equals 2 iterations. These are the authority scores. So what happens as we go to 4 iterations? Well, this is what you would find. And 6 iterations, this is what you would find. And same thing for the hub scores. These are the scores that we found so far with 2 iterations, and we can figure out what they are for 4 iterations and 6 iterations. So what you see here is that for some nodes, these scores aren't changing, but for others, they are changing. So here I'm highlighting the nodes for which the authority or hop score continue to change after 6 iterations. So for example, node B here starts out with an authority score of 0.15, then after 4 iterations it goes to 0.18, and after 6 iterations it goes to 0.19. So will this score for B continue to grow, or will it saturate at some point? What could happen here? And so if we continue iterating, here I'm showing you what happens to the hub and authority score of node B. So in this plot on the x-axis, we have the number of iterations, and on the y-axis, we have the authority and hop scores for node B. As it turns out, for most networks, as k gets larger, the authority and the hop scores actually do converge to a unique value. And in this case, this is the unique value that you find as k becomes larger and larger. And so for this network, the nodes with the highest authority score are B and C, and the nodes with the highest hop score are D and E. And if you remember the original setup of the network, B, C, and A were these root nodes, right? The ones that were supposed to be very relevant. And it turns out that B and C have the highest authority scores. And then the biggest hubs, the nodes that are good at pointing at nodes that are particularly relevant or particular authorities, are D and E. And if you notice, both A and D point to B and C, as well as other nodes. In particular, D only points to B and C, and E points to them too, and also others. Now, to compute the hub scores and the authority scores of a network using NetworkX, you can use the function hits and give it the graph that you're analyzing as input. And hits will output 2 dictionaries keyed by node that contain the hub and authority scores of all the nodes in that network. So in summary, we find that the hits algorithm starts by constructing a root set of relevant web pages and then expands it to a base set using the network structure. And then hits will assign an authority score and a hop score to every node in the network. And here, nodes that have incoming edges from good hubs are thought to be good authorities. And then nodes that have outgoing edges to good authorities are thought to be good hubs. Authority scores and hop scores for most networks will converge to a unique value. And you can use NetworkX to find these scores by using the function hits on any network that you want. And that is all for this video, and I will see you next time.